Hello dear students, today we will discuss about the vectors, the topic from two-dimensional motion from grade 11th. So it's very interesting, also very important topic of physics for grade 11th as well as for 12th also, because many topics are there in 12th standard which are based on vectors. So the basic knowledge of vector is very important for the grade 11th student, for the 12th purpose also. Coming to the what is actually vectors, what is vector quantity and what is scalar quantity. So first I'm explaining the scalar quantity. Actually physical quantities are classified into two groups. Physical quantities are classified into two groups. One is the scalar quantity and the second group is the vector quantity. So first, what is scalar and what is vector? What is the difference between scalar and vector, right? So scalar quantity, the quantities which require only magnitude for their complete representation. I am repeating, the quantities which require only magnitude for their complete representation are called the scalar quantities, right? Suppose I am trying to write mass, right? So suppose mass of any body is 2 kg. So if I am writing 2 kg, then it's complete, right? No requirement of writing direction because it's a scalar quantity. So the scalar quantity is what? The scalar quantity, the definition is the quantity which require only magnitude for its representation, or I must say complete representation, then this is called the scalar quantity, right? Now coming to the vector. So vector quantity is what? The quantities, this one, vector quantities, the quantities which require magnitude as well as direction for their complete representation. I am repeating, if any quantity, physical quantity require magnitude as well as direction for its complete representation, then we will say that particular quantity is vector quantity. For example, I am taking one example of that, suppose force is there, right? So if we want to write force, then if I am writing 2 Newton, it's not correct actually. Why? Because 2 Newton should be specified by the direction, whether it is acting towards north, it is acting towards south, it is acting upward or it is acting downward or in any particular direction. So the physical quantities which require magnitude as well as direction for their complete representation, these physical quantities are called the vector quantities. So the scalar quantities do not require any kind of direction for their complete representation, while the vector quantities require magnitude as well as direction for their complete representation. So the definitions are there, I told you. General vector notation, how can we a vector quantity represent? What is the representation of a vector quantity? A vector quantity is simply represented by an arrow, right? Arrow, the end point or the tail of that arrow will show you the starting point of that particular vector, and head of the arrow will give you the direction of that particular quantity. I am giving you for example, suppose I am representing any quantity like I am writing 2 Newton in terms of vector. This is the force. So examples of vector quantities are force, acceleration. These are the examples. Force, acceleration, displacement, etc. These are the examples of vector quantity. So if we want to write or represent any vector quantity, so it is simply represented by an arrow, right? This is the arrow. The head of this arrow will tell you the direction. This is called the head of the arrow, right? So head will tell you the direction, and this tail will tell you the starting point. Starting point, right? Head will tell you the direction, and tail will tell you the starting point of that particular quantity, physical quantity. And also the length of the arrow, this one, from here to here, will tell you the length. Suppose this is A and this one is B. So the AB, length AB will give you the magnitude of vector. It will give you magnitude of vector quantity. So what I told you, the vector is represented by an arrow, this one, and the direction of this arrow, that means head, will give you the direction of that particular vector. Tail of the arrow will give you the starting point of the vector, and the length of this arrow will give you the magnitude of vector. Right? I'm giving you another example. Like this is the vector, any vector A and B. Suppose the length of this is 2 meter and scale is 1 meter is equal to 1 Newton is the scale. So the 2 meter length means the force is 2 Newton, and suppose I am marking the directions. So this is east, west, north and south. Then we will say this is the vector of magnitude 2 Newton acting towards east, because the direction of this vector is along east. So this is the representation of a vector quantity. This is the representation of any vector quantity. Now, I have given you many examples of that. Now, classification of vector quantities. How many classes of vectors are there? How can we classify vector in different parts or groups? So, the base of classification of vector is the direction of the vectors. If we want to represent any vector in a specific direction, then on the basis of this direction, it is classified into two groups. So, to include all the possible direction, vectors are classified into two groups. One is the polar vector. One is the polar vector. So, what is polar vector? First, we need to understand what is polar vector. Polar vector are those vectors which have their specified starting point. Which have their specified or well-defined starting point. The vectors which have a specific or specified, well-known, what the starting point, right? These type of vectors are called the polar vector. So basically, the group of vectors are two. One, the polar vector, and other one is what? This is called the axial vector. Second group is there. So we are discussing here polar vector only. So the polar vector are what? The vectors having well-defined starting point. These are the polar vectors. So I am giving you one example of polar vector here. Suppose one vector is there, the velocity. So this is the velocity vector, right? We are representing the velocity vector here, right? That means what? This velocity vector having definite starting point. It is fixed starting point. So we will keep this vector in the group of polar vector. Displacement vector, velocity vector, force vector, many other are there. So these are the vectors which are having a specific or well-defined fix or the well-defined starting point. These vectors are called the polar vector. Now coming to the next, that is axial vectors. So what are axial vectors? Axial vectors are basically those vectors which do not have any fixed starting point, or simply, if you want to define them in proper way, so the vectors which cannot be represented in one dimension. They require one plane for their representation. Like, for example, any rotational motion, right? In case of rotational motion, we are trying to represent angular momentum. So angular momentum do not have any specific direction. That means it cannot be represented in one direction, one dimensional. So it requires one plane for their representation. These type of vectors are called the axial vector. The vectors which are described by a plane. These vectors are not confined along a straight line. That means they cannot be represented along a straight line. These vectors are called the axial vector. So torque, angular momentum, and any vector, angular velocity, any vector which is confined with the rotational motion are the axial vector. So this is the two classes of vectors. One, the polar vector. Other, the axial vector. Polar vector, the vectors having well-defined starting point are polar. The vectors which cannot be represented in a straight line or they require plane for their representation are called the axial. axial vector. These are the two classes of vectors. So all vector lie in these two classes. Now few definitions. That is position vector. What is position vector? Position vector, as the name suggests, position. This vector represents the position of any particular particle. So I am representing it. I am not going to the definition. The position vector is the vector I am taking. See, suppose any particle, this is x coordinate, this is y coordinate, right? This is any point P. Particle is situated at this point P. So what is position vector? Position vector is the vector joining this point with respect to any fixed point. It may be the origin or it may be any other location. So the vector representing the position of any particle is called the position vector. The vector representing the position of any particle with respect to any fixed point or origin, this vector is called the position vector. It is generally represented by R, putting arrow over there, because the representation of vector is by putting arrow on any physical, on any symbolic quantity, that is R. So this R is the position vector, right? So I am repeating, the position vector is the vector which represent the position of any particle with respect to any fixed point or origin. This is the representation of position vector. So it can be represented by this vector. So R is the position vector. Coming to the next, the displacement vector. So what is displacement vector? Displacement vector is what? As the name suggests that displacement means the movement from one point to another, right? So if any vector is representing this movement, then it will be a position displacement vector. How can we say that? Suppose any particle, for example, I am drawing here, any particle is here, like any particle is initially at A point, right? And this particle is moving to the point B, fine. Then the vector joining between these 2 points is the displacement vector. This vector AB, suppose this vector is del R, this vector represents the displacement vector, right? How? Because it is representing the displacement of the particle. That's why it is a displacement vector. So the definition is the vector joining the initial and the final position of any particle is called the displacement vector, right? It is represented by joining these 2 points, initial position and the final position of a particle, is called the displacement vector. Now, the next vector is zero vector or null vector. What is zero vector? Zero vector means the vector having magnitude 0. How can we define this? The vector which have 0 magnitude first and no specific direction. The vector having 0 magnitude and without any specific direction, this vector is called the zero vector. How can we get a zero vector? The point is that, how can we get a zero vector? Suppose any vector is there, A, right? This is the vector. And we are multiplying this vector by 0. Then whatever we will get, it is a zero vector. It do not have any magnitude, it do not have any specific direction. So this vector is the zero vector. Some characteristics of zero vector is there. Zero vector is the vector which is added to any quantity, any vector will give you the same vector, right? If it is subtracted from any vector, it will give you the same vector. If it is multiplied to any vector, it will give you the again zero vector. So this is the zero vector or the null vector. Also, if we are subtracting two equal vectors, means suppose one vector is A of magnitude 2 unit and along east the same vector magnitude 2 unit towards west. So if we add these two vectors, so 2 plus and 2 minus will give you the zero vector. So this is also the definition of zero vector. Coming to the next, that is equal vectors. So what is equal vector actually? Equal vector, as the name suggests, let me tell you it. So the equal vectors, right? Equal means suppose one vector is this A and another vector is there B with same direction, same magnitude. In vector, keep in mind, in vector the magnitude is important but more important is the direction. So if you are ignoring any one of them, it will be 100% wrong. So here the equal vectors means the vector having same magnitude, right, and same direction. These vectors are called the equal vector. If we want to write the opposite vector, here only, so if A is there, right, and B is there, these are the opposite vectors or negative vector. A is suppose plus 2 unit, then B will be, this B will be minus 2 unit. These are the opposite vector. These are not equal. These are not equal. They are having opposite direction, magnitude equal, but they are not equal. These are not equal. I also mentioned here, not equal. Suppose the unit, the 2 Newton is the unit, magnitude of this vector, and this is also of 2 Newton. Another vector I am drawing here, this is also of 2 Newton, right? Suppose this vector is A, this is B, this is C. So what do you think? A and C are equal? No, A and C are not equal. Why? Because A have this direction and C have other direction. So A and C are having different direction, that's why they will not be equal vector. So what is equal vector? Same magnitude, same direction. So that's all. Thank you so much.